Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm your host, Anna, and today we'll be covering a range of exciting topics from space debris to black holes, a spy story, and even space tourism. Get ready for a cosmic journey through the latest discoveries and developments in the world of space exploration. Let's kick things off with one of the biggest problems facing the space industry today, and fortunately, steps are being taken to address the problem. The European Space Agency is taking significant steps to address the growing issue of space debris with their innovative Zero Debris Charter. This initiative, launched in November 2023, aims to boost international cooperation in solving Earth's escalating space junk problem. The charter has gained impressive traction, with over 100 signatories joining the cause. At a recent ceremony during the International Astronautical Congress in Milan, 24 new partners signed on, including New Zealand and Mexico, the first countries outside Europe to do so. What makes this charter unique is its voluntary nature. It's not a regulatory document, but rather a collaborative effort within the global space community. The charter outlines goals and guiding principles, which will be developed into actionable and measurable targets. These principles include preventing intentional debris creation, anticipating and mitigating adverse effects, and promoting constant efforts to understand the problem. The charter also advocates for timely removal of spacecraft from orbit at the end of their missions and safe reentry practices. With an estimated million-plus pieces of debris larger than a centimeter orbiting Earth, this initiative couldn't be more timely. It's a crucial step towards ensuring that space remains clean and safe for future generations and ongoing space operations. Next up, this sounds like a plot from a James Bond movie, but it's a real concern. In a recent development, China has raised concerns about foreign espionage targeting their space program. The Chinese government claims that foreign spies are attempting to steal secrets related to their space initiatives. This revelation highlights the growing tensions in the realm of space exploration and technology. While details are limited, this accusation underscores the competitive nature of space programs worldwide. It also raises questions about international cooperation and transparency in space-related activities. As countries like China continue to advance their space capabilities, the potential for increased suspicion and security measures could impact global space relations. This situation serves as a reminder of the delicate balance between national interests and the collaborative spirit that has traditionally characterized space exploration. As we move forward, it will be crucial to monitor how these concerns shape future international space partnerships and information sharing. Next up, something making headlines in the astronomy world. In a groundbreaking discovery, astronomers have identified a unique triple system featuring a black hole with two orbiting stars. This remarkable find, described in a recent paper published in Nature, centers around V404 Cygni, a black hole located about 8,000 light-years from Earth. What makes this system particularly intriguing is its configuration. The first star orbits V404 Cygni every 6.5 days, so close that it's actually shedding material into the black hole's gravitational grasp. But it's the second star that's caught scientists' attention. This outer star is incredibly distant from the black hole, orbiting once every 70,000 years at a distance 100 times that between Pluto and our Sun. This discovery challenges our understanding of black hole formation. Typically, we believe black holes form from violent stellar explosions, which should disperse nearby objects. However, the presence of this distant star suggests a gentler formation process. Computer simulations indicate that the most likely scenario is a direct collapse, where the star that became the black hole simply caved in on itself without a dramatic explosion. This method would have allowed the distant star to remain gravitationally bound to the system. This triple system not only provides new insights into black hole formation, but also helps astronomers determine the age of V404 Cygni, estimated to be about 4 billion years old. As we continue to study this fascinating cosmic dance, we're sure to uncover more secrets about the nature of black holes and the evolution of our universe. Now, another story featuring the ESA. The European Space Agency's Euclid-mission has just released an incredible 208 gigapixel mosaic of the southern sky, and it's a sight to behold. This massive image covers an area more than 500 times larger than a full moon, giving us a tantalizing glimpse into the vastness of our universe. But Euclid isn't just about pretty pictures. This space telescope has a crucial mission: to help us understand the mysterious force known as dark energy. Scientists believe dark energy is responsible for the accelerating expansion of our universe, but we still know very little about it. To tackle this cosmic mystery, Euclid will map billions of galaxies across 10 billion light years of space. This preliminary data release is just a small taste of what's to come. Over the next 6 years, Euclid will survey an area thousands of times larger, creating the most extensive 3D map of the cosmos ever constructed. What's truly remarkable is that this initial mosaic, representing just 1% of Euclid's total survey area, already contains around 100 million stars and galaxies. Of these, about 14 million galaxies could be used to study dark energy's influence on the universe. As Euclid continues its mission, it will provide unprecedented insights into the structure and evolution of our universe, potentially revolutionizing our understanding of cosmology and the fundamental forces that shape our reality. In a recent development, NASA has put the brakes on plans to reduce operations of 2 major space telescopes as a cost-cutting measure. The decision regarding budget cuts for the Chandra-x-ray Observatory and Hubble Space Telescope has been deferred until after the agency receives its final appropriations for fiscal year 2025. This delay comes as a relief to many in the scientific community who were concerned about the potential impact on these vital instruments. The proposed cuts were significant, with Chandra facing a 40% reduction in its operating budget and Hubble looking at a 10% cut. The delay allows for more time to assess the situation and potentially find alternative solutions. It also highlights the ongoing challenges of balancing a diverse portfolio of missions within budget constraints. As we await the final budget decisions, the scientific community remains hopeful that these iconic telescopes will continue their groundbreaking work in unraveling the mysteries of our universe. Next, let's turn our attention to another big scientific discovery from way out there. In a groundbreaking discovery, astronomers have found one of the largest carbon-based molecules ever detected in deep space. The molecule, called Pyrene, was located within the Taurus molecular cloud, about 430 light-years from Earth. This finding is significant because it provides crucial clues that could help solve a long-standing mystery in astrochemistry: the origin of carbon, the building block of life. Pyrene is a polycyclic aromatic hydrocarbon, or PAH, made up of 4 fused planar rings of carbon. These molecules are among the most abundant complex molecules in the visible universe and are thought to make up roughly 20% of the carbon found in space. What's particularly intriguing about this discovery is that Pyrene was found in an extremely cold environment with temperatures as low as 10 Kelvin. This challenges our understanding of how these molecules form, as on Earth. They're typically created through high-temperature processes. The presence of Pyrene in the birthplace of our solar system provides a direct link between the early molecular clouds and the composition of celestial bodies like asteroids. This connection offers valuable insights into the chemical evolution of our cosmic neighborhood and potentially the origins of life itself. Finally, today, it looks like we have another space tourism provider on the horizon. In an exciting development for space enthusiasts, a Chinese company called Jiangsu Deep Blue Aerospace Technology has announced it's now taking pre-orders for suborbital space tourism flights, with the first launch planned for 2027. The company's CEO, Huo Liang, shared details of their commercial spacecraft during a recent live broadcast. Deep Blue Aerospace's plans include a reusable rocket called Nebula 1, which bears some resemblance to SpaceX's Falcon 9. Their spacecraft is designed to carry 6 passengers to an altitude of 100 kilometers, crossing the Kármán line, the official boundary of space. Passengers will experience about 5 minutes of weightlessness during the 12-minute flight. This move puts China in direct competition with established players in the space tourism market like Virgin Galactic, Blue Origin, and SpaceX. While these companies have already conducted successful flights, China's entry into the field could potentially make space tourism more accessible globally. That's all for today's episode of Astronomy Daily. I'm Anna, and I hope you've enjoyed this cosmic journey through the latest space news. Remember to visit our website at astronomydaily.io, where you can sign up for our free daily newsletter. Catch up on all the latest space and astronomy news with our constantly updating newsfeed. Find a bargain by checking out our sponsor links, and listen to all our back episodes. You can also find us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Thanks for listening, and keep looking up.